This is a video from section 3.4. It's on the chain rule. Let h of x equal f of g of x. H prime of x is going to be f prime of g of x times g prime of x. And so what we're doing is we're taking the derivative of the outer function, we're evaluating it at the inner function meaning g of x. And then we're going to multiply by the derivative of the inner function, which in this case is g prime of x. And with that in mind, we're going to look at some examples. So the directions say, find the derivative of the function. So let's go ahead and start with example 1. Suppose I had h of x is equal to x to the 5th plus 3x squared minus x raised to the 50th power. Now, the inner function, let's identify the inner function and the outer function. The inner function is going to be g of x is equal to x to the 5th plus 3x squared minus x. The outer function is f of x is x to the 50th. So when I want to get h prime of x, I'm going to take the derivative of the outer function. So I'm going to apply the power rule. So when I apply the power rule, I get 50 times something to the 49th power. But remember, we're evaluating f at this inner function g. So in other words, inside those parentheses, I'm going to put x to the 5th plus 3x squared minus x. And then I'm going to multiply by the derivative of that inner function. So in this case, I'm going to multiply by the derivative of x to the 5th plus 3x squared minus x. And so this is 50 times x to the 5th plus 3x squared minus x times, and that's to the 49th, by the way, times 5x to the 4th plus 6x minus 1. And that's how you would do the first example. So the key on these is to be able to identify that inner and outer function. If we look at example 2, suppose I had suppose I had capital F of theta equals cosine squared theta. Now, if you don't mind, I'm going to write this as cosine theta in parentheses to the second power, because here that allows us to define the inner and outer function. So the inner function is, we'll call it g of theta, is cosine theta. The outer function well, that's f of theta is theta squared. Okay? And so when I want capital F prime of theta, I'm going to apply the power rule here. But remember, when I pull the 2 out in front, I'm going to multiply it by some stuff to the first power, right? And what goes inside that parentheses is the inner function, this one. So that goes here. But remember, in the chain rule, you have to multiply by the derivative of the inner function, which in this case is cosine theta. So I like to think of this as peeling an onion. So remember, you're working outside in. So that's where the whole idea of peeling an onion comes in. You start from the outside, you work your way inside. So this is going to be 2 cosine theta times, remember that the derivative of cosine theta is negative sine theta. Okay? So this is negative 2 cosine theta sine theta. So, but I'm hoping you guys can get to this where you can say f prime of theta is negative sine 2 theta. So that's the trig identity for that. Let's go ahead and do another one. Let's call this example 3. Suppose I had capital F of x equals e to the tangent theta. So we need an inner function, like an inside function and an outside function. Well, the inner function is, we'll call it g of theta is equal to tangent theta. The outer function is f of theta is e to the theta. Okay? Oh, and let me make sure that that matches. So we should call that f of theta, by the way. So f prime of theta. Okay? Now, the derivative of e to the theta is e to the theta. So we're going to take the derivative of the outside function, but we're going to evaluate it at tangent theta. So we're going to get e. So instead of writing a theta, we're going to write e to the tangent theta. So we're going to write e to the tangent theta. And we're going to multiply by the derivative of tangent theta. And remember that the derivative of tangent theta is secant squared theta. So I'm going to write secant squared theta times e to the tangent theta. And so that right here is f prime of theta. And they take practice, and it takes time to get faster at them, but it does happen, okay? So if we want to take a look at example 4, suppose I had f of t equals t times sine pi t. Now, this is a product rule problem, okay? So when I want to take the derivative, I'm going to take the derivative of the first multiplied by the second. So the derivative of t is 1, and I'm going to multiply by sine pi t. Okay? And then I'm going to add. I'm going to add t times the derivative of sine pi t. Now, before we finish this problem, let's come over here. Suppose I let y be sine pi t. So let's make sure we're okay with this. The outer function is, we can call it, well, f is already being used, so we'll call it h of t. is sine t. The inner function is g of t, is pi t. So if I want y prime, so I'm going to take the derivative of the sine function, which is cosine. But remember, I'm evaluating it at this inside piece, which in this case is pi t. But I have to take the derivative. Well, I'm going to take cosine of pi t, and I'm going to multiply by the derivative of pi t. But the derivative of pi t is pi. And so this ends up being pi cosine pi t. And so I'm going to take that derivative and transfer it over here. So we just determined that the derivative of sine pi t is pi cosine pi t. And so if I just rewrite this a little bit, f prime of t is sine pi t plus pi t cosine pi t. So that right there is the derivative. So this is a combination of the product rule and chain rule. Let's take a look at another problem. So we'll call this example 5. Suppose I had the following. We're going to do this one. F of x is e to the negative x times cosine of x squared. Okay. Now, this is a classic product rule problem, but within the product rule, you must apply the chain rule. So if I take the derivative of e to the negative x, it turns out that the derivative of e to the negative x is e to the negative x times d dx of negative x. Here, let's do this. Before we do this, before we apply the product rule, we're gonna attack it this way. I'm thinking this will help you guys. Now, so what I'm going to do is I'm going to let, we'll call it h of x equal e to the negative x. So I claim h prime of x is negative e to the negative x. So if you apply the chain rule, I claim this is what you're going to get. Okay? And then if g of x is cosine of x squared, g prime of x is the following. You're going to take the derivative of the cosine, which is negative sine, but you're going to evaluate it at x squared. And then what you do is you're multiplying by the derivative of the inside function, which is 2x. And so this is negative 2x sine of x squared. Now what we're going to do is put these pieces together. So we're going to look at f prime of x, but we need to apply the product rule here. So the derivative of e to the negative x, again, is negative e to the negative x. So let's write that down. Negative e to the negative x. But we're going to multiply by cosine of x squared. Plus e to the negative x. And then I multiply by the derivative of cosine x squared, which we figured was negative 2x sine of x squared. So that goes here. And so if we simplify this a little bit, I'm going to factor out an e to the negative x, and then I'm going to multiply by negative cosine of x squared minus 2x sine of x squared. And by the way, it's entirely possible that your instructor might want you to factor out that -1 as well. So just, it's something to keep in mind. Okay? Let's do one more example for this video. So we're going to look at example 6. Suppose y equals e to the sine 2x plus sine of e to the 2x. And I want to look at y prime. So let's take a look at that first term. So I'm going to get e to the sine 2x. So remember that the derivative of the outer function, we're looking at the exponential. So we're going to take e to the sine 2x. We're going to multiply by the derivative of the inner function. The inner function is sine 2x. And then I'm going to go plus. The derivative of the outer function is cosine, right? So the derivative of sine is cosine. So we're going to do cosine of e to the 2x, and I'm going to multiply by the derivative of e to the 2x. I hope that makes sense. And so when I put this together, y prime is e to the sine 2x multiplied by, over here, I'm going to write 2 cosine 2x. And then I'm going to add cosine of e to the 2x times 2e to the 2x. And there's not a whole lot you can do with that other than to factor out the 2. And that would be the derivative of this function. So you're basically applying the chain rule twice. And that'll conclude this video for section. This is 3.4, and we worked through 6 examples of the chain rule. And we did an alternate version of the chain rule in these 6 examples. So, okay, thank you.